grade 8 students, welcome back to our math tutorial. For the fourth quarter, our weeks 1 and 2 have actually the same topic, that is on theorems on triangle inequalities. So for these 2 weeks, we will be focusing on the 3 theorems on triangle inequalities, that is exterior angle inequality theorem, triangle inequality theorem, and hinge theorem. So for this tutorial, I will be giving brief explanations and examples on these 3 theorems. So just sit back and relax. Let's get started.
Exterior angle inequality theorem. Now this theorem talks about the relationship between the exterior angle and its two non-adjacent interior angles. Given this figure, angle 4 is the exterior angle of the given figure. Angle 1, angle 2, and angle 3 are the interior angles of this triangle. Angle 3 is adjacent to angle 4, so meaning they form a linear pair and at the same time they are supplementary, while angle 1 and angle 2 are the two non-adjacent interior angles of angle 4. We can also call this one as remote interior angles. Now the theorem states that the measure of each remote interior angle is less than the measure of its exterior angle. So we can conclude that measure angle 4 is greater than the measure of angle 1 and the measure of angle 2, or the measure of angle 1 and measure of angle 2 is less than the measure of angle 4. Let's have another figure. So we have here angle 1, angle 2, and angle 3 are the exterior angles of the given figure. Angle 1, its remote interior angles are angle 4 and angle 6. So therefore, the measure of angle 1 is greater than the measure of angle 4 and angle 6. Angle 2 is another exterior angle. Its remote interior angles are angle 5 and angle 6. The measure of angle 2 is greater than the measure of angle 5 and the measure of angle 6. Angle 3 is also another exterior angle. Its remote interior angles are angle 5 and angle 4. The measure of angle 3 is greater than the measure of angle 5 and also greater than the measure of angle 4. Triangle inequality theorem. A triangle cannot be formed by just any set of 3 random lines. So meaning you cannot just give any dimensions or length of the sides of a triangle. It must observe the triangle inequality theorem, which states that the sum of the lengths of 2 sides of the triangle will always be greater than the length of the third side. Therefore, this is a useful tool for checking whether a given set of 3 dimensions will form a triangle or not. Given the figure, we have triangle ABC. This is angle A, angle B, and angle C. You can name side AB with a small letter C. You can also name side BC with a small letter A. And you can also name side AC with small letter B. So we have side A, side B, and side C. So using the theorem, it states that we have to add the length of the 2 sides and we have to make it sure it is greater than the length of the third side. So we have AB plus BC is greater than AC, and then AB plus AC is greater than BC, and then BC plus AC is greater than AB. You can also use the small letter. A plus B is greater than C, A plus C is greater than B, and B plus C is greater than A. So these are the conditions that will help us determine that the 3 dimensions are possible to draw a triangle. Let's have this example. We are going to determine whether it is possible or not to draw a triangle with the given side lengths. Now, if you notice, there were 3 conditions I gave a while ago. We can simplify the 3 conditions. You just add the 2 smaller lengths and then compare it to the remaining length. If it is greater than, then it is possible to draw a triangle. But if it is less than, then it is not possible to draw a triangle given this side length. Let's have number 1. So we'll only add the two smaller lengths. That's 10 and 11. 10 plus 11 is 21. Is it greater than 13? Yes. So therefore, these three side lengths are possible in making a triangle. Let's have number 2. 21 plus 9, that is 30. 30 is not greater than 38. Therefore, these three side lengths are not possible to draw a triangle. 20 plus 20 is 40. It is not greater than 41. So therefore, it is not possible to draw a triangle. 4.5 and 8.5. That gives us 13. 13 is greater than 12.5. Therefore, it is possible to draw a triangle using these side lengths. Number 5. 24 plus 45. That gives us 69. 69 is not greater than 90. Therefore, these side lengths are not possible to draw a triangle. We can also determine the length of the third side using the same theorem. So, given these two lengths of two sides of a triangle, we have to find the range of the possible length of the third side. Now, let's try to make it simpler. So, this will be the length of the third side. It is greater than the difference of the two sides and at the same time less than the sum of the two sides. So, let's have this example. Given is side A is 5 cm and side B is 7 cm. So, if we want to get the length of side C, we have to subtract both. That gives us 2 cm. And then we have to add. That gives us 12 cm. So therefore, we can conclude that the length of C is greater than 2 cm but less than 12 cm. So it's either 3, 4, 5, 6, 7, 8, 9, 10, 11. Number 2, given is A is equals to 6 cm and C is equals to 8.5 cm. So we subtract. That gives us 2.5 cm. And then we add. That gives us 14.5 cm. So to conclude, the length of B is greater than 2.5 cm but less than 14.5 cm. So the possible length is just between these two numbers. Number 3, B is 7 cm and C is 9.5 cm. So we subtract them. That gives us 2.5 cm. And we add them. That gives us 16.5 cm. Therefore, the length of side A is greater than 2.5 cm but less than 16.5 cm. Hinge theorem. The hinge theorem states that if two triangles have two congruent sides or sides of equal length, then the triangle with the larger angle between those sides will have a longer third side. This also gives us way to the converse of the hinge theorem, which states that if two triangles have two congruent sides, then the triangle with the longer third side will have a larger angle opposite that third side. Now let's look at the given figure. We have here the first triangle and the second triangle. The first triangle has sides A, B, and C. The second triangle has sides D, E, and F. Now if you notice, based on the markings, side A and side D have equal length. Side B and side E have also equal length. But the angles between these two sides are not congruent. This triangle has a smaller angle compared to this angle in the second triangle. So based on the theorem, we can say that the length of C is less than the length of F. Or you can do the reverse. The length of F is greater than the length of C. Let's have an example. let's look at this figure. We have triangle CPM and triangle RPM. So this side is common to both triangles, so meaning this is congruent already. Then from the figure, we have their CP and PR have also equal length based on the markings, but their angles between these two congruent sides are not the same. So we have 53 degrees and 55 degrees. The side opposite 53 degrees is segment CM, and the side opposite 55 degrees is segment RM. So we have to compare the length of these two sides. So CM, since it is opposite the smaller angle, is less than RM, since this is opposite to the bigger angle. So this will be your symbol. CM is less than RM. Now, using its converse, so you'll be comparing this time the angle. So we have there, this side has length 8 units. This one has also length of 8 units. So these two are congruent. This side is common to both triangle. So that's the second congruent side. So we have angle 2 and angle 1. Angle 1 is opposite the side with length of 9 units, while angle 2 is opposite to the side with 7 units. So we have to compare measure angle 1 with measure angle 2. Since measure angle 1 is opposite the longer side, measure angle 1 is greater than the measure of angle 2 because angle 2 is opposite the smaller side. So we can say that measure angle 1 is greater than measure angle 2.
That's it. I hope it's clear to you. Thank you for listening and have a good day. See you on the next tutorial. Once again, this is your math teacher, Bunyesa Kappa.